Hey everyone, today we are going to be talking about graphing reflections of points. So we're going to talk about graphing reflections over the x-axis and the y-axis. A reflection is the mirror image produced by flipping a figure across a line in the coordinate plane. When you reflect a point, you name the reflected point by using prime notation. So this right here is the original point. If I were to fold this graph in half across the y-axis, that's this one right here, my reflection would end up on this point right here, and you can see this right here. This A has a little apostrophe on it. That's called prime notation, and it says in this information, in the figure, the point A, -4, 0 is reflected to A prime, 4, 0 across the y-axis. So we're going to talk about reflecting across the x-axis first, and then we're going to reflect across the y-axis. So it says, write the ordered pair that is a reflection of -3.5, 2 across the x-axis. So the first thing I'm going to do is I'm going to highlight the x-axis. So this is the axis that I'm reflecting over. So for my reflection, it's as if I'm taking my piece of paper, my graph paper, and I'm folding it in half on this x-axis. And I want to know where this point A is going to end up. So I'm going to count the number of spaces away from the x-axis that I am. So 1, 2, and then I'm going to count the same number of spaces to the other side. 1, 2. And this is going to be labeled A prime. Now the coordinates of this A prime are -3.5. So my x values stay the same. So it says when a point is reflected across the x-axis, the x coordinate stays the same. And then my y coordinate actually changes. So it went from +2 down to -2. So the y coordinates are opposites. So A prime is -3.5, -2. So in this next part, I just have some extra examples here. So it says use the coordinate plane to reflect 3, 2 across the x-axis. So I'm going to plot 3, 2. 1, 2, 3, up 2. So here's A. I'm going to highlight my x-axis. So here's my x-axis. I am 2 spaces away, 1, 2. So I'm going to count 2 spaces to the other side, 1, 2. And here's A prime. So A prime is going to be 3, -2. -4, 2, 1, 2, 3, 4 to the left, up 1, 2 is here. And then I'm going to reflect again across the x-axis. So 1, 2, 1, 2. My x coordinate for B prime. So this is B and B prime. My x coordinate is going to stay the same at -4, and my y coordinate is going to become a -2. So my x stayed the same, my y is the opposite. My x stayed the same, my y is an opposite. So now we're going to look at reflecting across the y-axis. It says Delaney is building a square fence. She places fence posts at the locations indicated on the grid, so the 4 corners would be your fence posts. It says, what is the location of the post that reflects S -2, 2, so that's this point right here, across the y-axis. So now I'm going to use this up and down axis. So when I count this, because this graph is counting by 0.5s, I can still use the counting of the actual boxes. Instead of counting by halves, I can just count the number of boxes that I am away from the y-axis and then go to the other side. So 1, 2, 3, 4. So 1, 2, 3, 4. So here's my fence post right here. That's going to be my S prime. And this point, the x coordinate is the one that changes because now I'm over at +2 and my y coordinate stayed the same because I'm still up at +2. So when a point is reflected across the y-axis, the y coordinate stays the same and the x coordinates are opposites. So this S prime is 2, 2. So my original point was -2, 2. My new point is +2, 2. And just like the x-axis, we have some extra practice of the y-axis. So I'm going to highlight my y-axis here really quick. So I'm reflecting across this one. So my first point Q is negative 4 comma 4. So negative 4, 1, 2, 3, 4, 1, 2, 3, 4. So this is Q. And I'm again going to count towards the y-axis. So 1, 2, 3, 4 spaces. So 1, 2, 3, 4 spaces. There's Q prime. So that's going to be positive 4 comma 4. If I plot 2 comma negative 3, 1, 2, 1, 2, 3, that's B. So I'm going to count to the left this time, 1, 2, and then go 1, 2 more to the left. So this is B prime. And again, my x coordinate is going to change. So I'm negative 2 to the left now, but I'm still down at negative 3. So now we're going to practice just a few of them without using the graph. So across the x-axis, x stays the same. Y is the opposite. And this one, y stays the same. X is opposite. And what's going to be helpful on these is if you state which one is supposed to stay the same. So this says, without using a graph, write the ordered pair that is a reflection of each point across the x-axis. So I want my x coordinate to stay the same. So when I write my new ordered pair, it's going to be negative 2, comma. This one is going to be negative 5, comma, and this one is going to be 2 3/4, comma. My x is supposed to stay the same, and now I'm going to flip my y coordinate. So positive 3, the opposite is negative 3. Negative 6, the opposite is positive 6. Negative 4, the opposite is positive 4. So across the x-axis, x stays the same, y is the opposite. Now the next one says, without using a graph, write the ordered pair that is a reflection across the y-axis. Well, if it's across the y-axis, then y stays the same. So here it's going to be comma 3, here it's going to be comma negative 6, here it's going to be comma 5. And then I have to flip my x coordinate. So the opposite of negative 8 is positive 8. The opposite of negative 7 is positive 7. The opposite of 2 3/4 is negative 2 3/4. Okay. So the important thing is here, without a graph, is to identify which axis you are flipping over and then which coordinate stays the same as a result of that. In example 4, we're talking about which one is the axis of reflection. So again, we're going to talk about how when you reflect across the x-axis, the x coordinate stays the same and the y is opposite. When you reflect across the y-axis, the y stays the same and the x is the opposite. So we're just repeating that idea again because we're just going to continue using that through all of this. So this says point A, negative 2 3/4, comma 4, is reflected to point A prime, negative 2 3/4, comma negative 4. Identify the axis across which the point was reflected. This says to compare the points. Which coordinate stayed the same? Well, if I look at my ordered pairs, negative 2 3/4 is the one that stayed the same. So I'm going to say x stayed the same. So if x stays the same, I reflect it across the x-axis. In part B, it says negative 2 1/3, comma negative 1 is reflected to m prime 2 1/3, comma negative 1. So again, I'm going to identify the one that stayed the same. Well, here negative 1 stayed the same. So y stayed the same. Since y stayed the same, it reflected across the y-axis. If you are given a graph to do reflections, plot the point and count the boxes to the line of reflection and then count to the other side. It's as if you're folding that paper in half. Where would that mirror image end up? It is possible to do these without the graph. So if you're reflecting across the x-axis, the x stays the same. If you're reflecting across the y-axis, the y stays the same.